In an earlier lesson, I explained that polymorphism is the ability of an object to masquerade as an object of any class or interface from which it is constructed. This lesson explains how you do that. It's done with references. The web page you're looking at is the Sun API documentation for a class named Java AWT Canvas. A canvas object is a graphic component that displays an empty window you can draw into. As you can see, this class extends the component class, which in turn extends the object class. It also implements the interfaces accessible, image observer, menu container, and serializable. Now, it could be that the canvas class does the implementation or the component class does the implementation. It doesn't matter. The result is the same. The point is that a canvas object can morph into an object of any one of these types. I've written a small program to show you how that works. Now, look at these first 3 lines. Each one declares a reference to a different type of object. The object's in the lines of inheritance of the canvas class and creates a canvas object and stores it in the reference. Now, these are all 3 canvas objects, but they're also component objects and object objects. That's why they can be stored into references of those types. If you can store the address of an object into a reference, it can be treated exactly as if it were an object of that type. Well, it actually is an object of that type. It may be some other things too, but you can't address anything except the things that are defined in the type of object being defined for the reference. Now, this statement requires a casting to morph the object to another type. The first statements didn't require casting because every canvas object is a component object. There was no ambiguity. But this line of code is different. Not every component object is automatically a canvas object. The component could be a button or a menu or something else, so the casting is necessary. If it turns out that the object cannot be morphed into a canvas, a runtime error will occur and the program will just quit running. That's where this line of code comes in. The instance of operator can be used to make sure the conversion is possible before you try to force the assignment. The instance of operator will give you a true response for anything that the object is or can become. Here you see the object being morphed into each of the 4 interfaces that are implemented by the class or by one of its superclasses. No casting is necessary because a canvas is each one of these things. One thing that is new here is that you can create a reference to an interface just like you can a class. You can create a reference to any interface and to any class, whether or not the class is abstract. References are possible even for things that you can't instantiate because you can always use them to morph objects into them. This brings me to a couple of terms that may be on the test. You may have heard the term is-a and has-a. These are a couple of popular object-oriented words that you'll come across from time to time. The term is-a refers to what an object is. That is, a canvas object is a component object and it is a serializable object. If the instance of operator returns true, then the object is one of those things. The term has-a means that the object contains another object of the other type. For example, the canvas class contains a window object somewhere down inside. It doesn't inherit from the window class. It uses the new command to create a window object and stores that object in a reference somewhere inside. Therefore, the canvas class has a window object but is not a window object.